lead conversational initiatives, all the AI initiatives at Haptic. And welcome to Conversation.ai. I think so. Conversation.ai is an initiative by Haptic, primarily meant for knowledge sharing and sharing experiences from across the AI spectrum. And glad to share that today we have Sandeep with us. Sandeep has been a veteran in the industry, and he has. I think Sandeep, welcome to Conversation.ai, and just to tell a little more, Sandeep has traversed through academia, large tech company. He has mentored startups, so more or less seen all entire spectrum across the industry. And even his research, I think, spans across neuroscience, voice tech, and timing, fundamentals of the timing. And yeah, I think Sandeep, that's like such a multidisciplinary overall experience that you have. Why don't sort of you take a few seconds to introduce yourself and tell us slightly more about the overall journey.
Sure. Firstly, thank you, Kripal, to you, Prateek, Akrit, and the team at Haptic for having me here. So I think I've been quite fortunate to have a career that has spanned multiple domains, multiple countries as well. And I started off here in India as an engineer in Delhi. And then I realized at some point during the end of my degree that I didn't want to be yet another engineer. And somehow I got into touch with the neuroscience. So I think the connection wasn't that far off, given I was studying electronics, and the brain is a very complex electrochemical network. And I just had the conviction when I first read that, I really want to know more about the brain and so the most mysterious and sophisticated systems out there. So I took a huge leap of faith, decided not to go ahead with the established path, given my father, my brother's an engineer, and I ventured into the unknown. Was lucky again to get um, a master's position at Oxford University to learn neuroscience from scratch. And once I was there and I started doing experiments in neuroscience, looking inside the brain, recording from single neurons, I was hooked. So that sort of began my academic career in neuroscience. I continued doing a PhD at University College London, where I focused on speech recognition mostly, but also touched aspects of language, memory, and timing. And then it was, going again on the established academic path towards becoming a professor. So I had my own research funding. I was back at Oxford, but then I realized that I wanted to have more impact and work on things that can touch either the consumer or the enterprise. So I decided I was again got an offer from Amazon Alexa to join their team in Seattle to work on the Echo product, and I decided to take that chance with both hands. And it's a decision that I do not look back, even though a lot of people told me at that point, "Hey, you're well set to becoming a professor. Why are you doing this?" But I was convinced that I wanted to understand the problem from a technological perspective as well. So I spent a couple of years in Alexa in Seattle and worked on speech recognition, NLP, NLU. And then I decided to come back to India after more than a decade outside the country. And here in India, I joined Swiggy. Uh, and I was here in the AI team leading work on both NLP and voice AI. And after almost a year, I left Swiggy to go on to work on my own startup. So, in a nutshell, I've been across different experiences, and I think I've always chased new experiences. That is what sort of got me where I am
Absolutely,
today.
actually. So honestly, truly, like when I first saw your profile, I was like most of us by now know that most of the problems of tomorrow will need like a multidisciplinary approach to actually solve some of them. Uh, so like, any instances in your career where, just the breadth of knowledge across sort of voice, language, timing, neuroscience help you, like, sort of a motivation from one of the fields ended up, sort of giving you another motivation for sort of across the different domains.
Absolutely. So I think that was one of the things that drew me into AI in the late, I think, 2016, 2017. So as a neuroscientist, I've recorded from single neurons and populations of neurons in the brain. And although you can make sense of certain response functions or how neurons behave under different conditions, I was drawn by the kind of products and systems being built using deep learning. So then I decided to transition to that side, and I realized that so much of deep learning is inspired by how neurons actually work. So to give you certain examples, like the concept of dropout in deep learning,
Yeah.
where not all neurons are active all the time, is very commonly known in neuroscience that
Got
cells
it.
are firing very stochastically, and there's no regular structure to the firing of individual neurons. So that is one aspect. Then even certain concepts, let's say like right now, um, attention, for instance,
Right.
capturing context, focusing on what is being attended to right now, helps you understand or understand the context over the longer term. So there's a lot of cross fertilization of ideas, and when you have experience in different domains, just like an AI system, it becomes easier for you to generalize across certain common trends or patterns.
All right.
And that helps you come up with newer ideas. Otherwise, you tend to develop tunnel vision if you're in one domain. And you need ideas from outside, from people from various different domains, not only in neuroscience or in physical sciences, but also outside, arts and humanities as well.
Yeah, absolutely. Yeah, I think I take your point for that. The example which you took, attention, probably one of the, I would say, best breakthrough in last decade when it comes to deep learning. Yeah, great example. I have one more thing which I wanted to know. So, like, let's say, currently, as a smaller research setup, uh, there is always just so much going on across different research trends. For example, if you take an example of NLU, then, like, there's obviously one trend of building bigger transformers, and
Mm.
that's one set of trend. Then obviously there's another trend of sort of somehow utilizing the structure of the language, which goes into the knowledge bases and ontology, and mostly in that direction. And then obviously there is several other trends sort of emerging from linguistics, cause effect relationships, and so on. So a combination of academia and industry. There are just so many research trends which are emerging in order to solve a particular problem. Uh, uh, how do you think, like, let's say a smaller research team uh, can successfully absorb first of all the variety of things which is going on, and also make some productive application of the same? So what do you think is the key to sort of identifying the right thing to focus on, I would say?
Right, right. And that's a very interesting question. I think that's a question that a lot of applied research teams in
Correct.
startups or even smaller teams in bigger companies face. So I think it's a question of balance between focusing on ideas or research directions that might play out or prove successful in the longer term, as well as focusing on immediate low-hanging fruits that you could solve quicker to drive immediate business impact. Because if you're in a product-driven company or in a commercial entity, you have to show the value of your team's work, right? So
Yeah,
that's
absolutely.
always a challenge. Yeah.
That's exploration exploitation trade-off.
Absolutely. So there's that trade-off always. So you need to have both depth and breadth in the topics that you're interested in. And I think one of the things that helps a smaller team focuses working backwards from, let's say, what is the core product of the company, or let's say within that product, what are the core pain points that either the customer is facing, or which can improve your product, much more and give you greater ROI. So a lot of sort of this brainstorming needs to happen upfront to see out of, when you evaluate 10 different potential ideas, which of these ideas can give you maximum return in the smallest amount of time. And then you weigh that trade-off across different ideas and focus on, let's say 80% of your effort on things that will drive immediate business impact and maybe 20% on slightly longer term goals.
Got it.
And this balance varies according to the team or this, or the culture within the startup or the company as well.
Got it. Got it. So when even when we talk about the culture in startups or like in a mid-sized team, for example, take an example of a haptic. At least people who focus on machine learning and NLU at haptic, we're a small team of like 8 people,
Right.
group of 8 to 10 people, sort of keeping track of pushing our accuracy ahead. So, just a question: when it comes to culture, I think what do you think is even the key to the building the culture of innovation? So, it is very easy to it's always tempting to grab the low hanging fruits, like for like 1% or 2% or 3%
True.
accuracy improvements. Uh, but what do you think, like specifically in these kind of setup, is the key to like right culture, which sort of nurtures innovation?
Absolutely. So I think culture usually tends to flow, from the top, and the leaders set
Correct.
the tone for it. So I think, as I said earlier, it's important to have a longer term vision. Like, this is our North Star for our product or for our startup, and we want to eventually solve it. And you need to encourage people within your team and excite them by the mission statement that you have, right? So let's say we want a chatbot which can be highly contextual, speak in multiple languages, and talk across several different domains that your clients might come from. So let's say that's the North Star for Haptech, but
Yeah.
it's not something that can be realized quite soon. So while that is the North Star, you slowly incrementally build smaller achieve smaller milestones and wins to head in that right direction. So I think it's important to keep that focus uh, towards a long-term goal and encourage teams who are focusing. And the reality right now is that a lot of data science, machine learning work, although from the outside looks glamorous, but inside it's a lot of data wrangling. We're dealing with
Absolutely.
pipelines and a lot of bugs and
Yeah,
errors.
yeah. I think tagging of data is underrated everywhere.
True.
At least in a smaller setup, even today, it is highly underrated.
Absolutely, absolutely. And if the data is not labeled right, then no matter what kind of models you build, right, there will be that error in the system. So every aspect of the ML lifecycle is equally important. I think the kind of mindset that is important to have is that of a scientist. So first principles thinking, hypothesis-driven approach. Keep doing lots of experiments and try to prototype quickly and do experiments quickly. See which ones work, which ones fail, and that will help you build more intuition towards focusing on the right kind of ideas that will help you achieve your short-term and long-term goals.
Correct, correct. Absolutely right. I think but I agree to it that even today, like let's say all uh, components of the entire life cycle don't really end up getting equal attention, I would say. There's obviously a when it comes to like generating 10,000 or 100,000 records, it sounds like a daunting task, and I think I've seen many data scientists taking shorter routes to like at least compromising with the quality of data.
Right, right. Yeah, that tends to happen exactly. Yeah.
Yeah. And another thing actually with this, I also sort of want to know that when we say, like you said, first principles thinking and sort of always starting with a hypothesis and validate it with a quick prototype. Uh, well, that is like, I guess that's truly what sort of we aspire to stick to. Uh, while there are, several sort of, challenges which I would say we generally come across. I'll actually give you some example so that we would love to have your inputs on how to deal with those situations.
Mhm.
But so let me put it this way. So like let's say every almost every month there's a trillion parameter model which is coming up now.
Right.
Every month a new model with a trillion parameter sort of has been coming up since almost last year or so at least,
Right.
right? So while the research on that front is something which is quite a lot of very heavy, that's a very heavily invested research area in itself, right?
Mhm.
Now when it comes to scaling, right, there are other research directions which also needs to progress in order to make sense of these larger models. So let's say the research directions of distillation of the models or pruning of models or quantization of models, uh, those directions also need equal progress in order to actually leverage these large models into a viable sort of at a viable scale,
True.
I would say. uh, so how do you know, how do you like always keep track of these how do you determine these blockers ahead of time? So let me put it this way. So like let's
Mm.
say while building larger models is a research trend which shows reasonable improvement in accuracies, etc., as long as the research on the distillation is not progressing, probably any prototypes which are made using larger models may not work out in a practical setup. Uh,
Absolutely.
so, so
Right. So that dichotomy is always there between academic research and, let's say, applied research in industry. So let's say take the example of BERT. It was the first model that was
correct,
improved a lot of the state-of-the-art benchmarks, but people realized that it's too big to actually store in RAM and
correct,
deploy a model into production, which then triggered the research of distillation. So now you have smaller models like your Albert or Distilbert,
yeah,
and
I think that's some great work which Hugging Face
exactly, exactly. So people realize that although these models are giving us high accuracy, but they come with the problems of too big memory and number of parameters, and not being able to fit in the let's say a GPU memory, right? And a lot of sort of new ideas and like the applicability of these ideas depends on the particular use case. So if you're deploying a model in the cloud, you can get by with using a bird-based model. But if you have to deploy, let's say, a chatbot or an NLU engine on device, then you will face these practical challenges.
yeah,
And
yeah,
let's say you're in a system, you're in a domain like healthcare or finance, where explainability or interpretability is very important, right?
correct,
How do you peer into these black box models to give that kind of explanation to a customer or a client as to
got it,
why certain things work, why don't they work? So, like academic sort of, while there'll always be a line of work which will be continuing to improve upon the state of the art, higher and higher accuracy, surpassing, let's say, human standards. From the industry point of view, for a startup to actually, you make use of that research into applications, new set of research directions come up, as you mentioned, knowledge distillation, or quantization, or pruning, or even like new kinds of chips, right? So new
yeah,
kinds of AI chips are
correct,
being developed to have
correct.
faster computation, or even deploy bigger and bigger models on smaller and smaller devices. So that's the nature of research and application going hand in hand.
Yeah, yeah, absolutely. So, actually, that reminds me of one of the great examples of where, uh, voice to tech. Let's just so one really great example of the place where the entire use case is actually needs just so much thinking just because of some of the technology limitations. I'll
Right.
actually take one example. So haptic also supports voice bots apart
Hmm.
from chatbots. So while we were building towards sort of building a better stack for voice, one of the challenges which came across for one of our product managers was that hey, I can't collect names and emails over voice. So let's say
Mm.
in the current state of technology, or I don't even know in the even in the future, like let's say so generally, in for business conversations, people do exchange their name, emails,
Right.
etc. over
Right.
support conversations, right? For confirmation. So let's say
Yes.
if you were to call a customer support, they might ask you for some of your details for confirming. A very simple challenge where if you say my name is Sandeep, as if we are using a voice to text system for validating this accurately, I can't really, I think your name is the best example for that. I don't know whether it's SAND or SUND, or
Right.
if someone says Pratik, I don't know if it's IK or it's double EK. So again, like, that just went over, and that'll obviously open a different set of challenges for product as to, like, if we are, if someone was to build a voice agent on haptics platform, how do you limit them from making such mistakes, or like how do you even guide them on
True.
building with certain limitations?
Right. Yeah. So I think that's always going to be a challenge as how we build AI models and products that are very like that are easier to interact for the average customer. And this interaction between human and AI is something that is very dependent on, let's say, location or culture or even language, right? And that is where like product management and people who work closely with the customer can make a good assessment of what is the right way to deal with certain things. So should we collect these important business information over chat or voice or a hybrid model, right?
Yeah,
So
absolutely. So, like, let's say
exactly.
these kind of limitations would actually, straight away hit the designer as to, like,
True.
what's the right way to uh, have a voice interaction as well as have some window for collecting details, which you can possibly, like, at least today, you can't really, collect them accurately over voice.
True.
Uh,
True.
yeah, I think that brings me to another question about, like, adaptability of some of these research trends. So let's say at least as this voice, while we are at it, like, uh, any thoughts from your experience at Amazon, maybe regarding the how difficult it is to actually scale voice across geographies and across accents, and sort of obviously when dialects for a country like India. So how do you think, like, that specifically how what is your perception on, like, at least the time frame in which it would be adopted, or, like, the challenges which needs to be solved for better adoption?
Right, right. And that's a very important question because every company is looking for a global audience for their AI products. So let's say if we talk about Alexa, it's present in US, UK, France, Germany, Japan, India, right? And the languages, by their very structure and usage, are so different in these countries. And the problem, let's say, with India is that we tend to mix languages. We speak Hindi, we speak
Yeah.
English, we combine other regional languages. So that makes it very challenging for the sort of the company or the product or the team working on it to have a single model that will solve for all these different markets, so to say. So I think initially a modular approach works well. So you try to fine tune for a specific market. So let's say English is standard language spoken across the
Correct.
US. So it becomes easier to do that. Now let's say if we talk about India, we want to solve for Indian English first, then let's say Hindi, and then the other languages depending on the market. And then there's a challenge of understanding the linguistic structure of each language, collecting data,
Correct.
annotating it. So the initial sort of work will, I mean, there'll be a lot of groundwork to develop these things. But at the same time, there are certain sort of technological approaches that we can use. So let's say we can use transfer learning
Correct.
to use a model, let's say that's been developed for American English for Indian English, if we do not have much in Indian English data, right?
Got it.
So you can always combine certain things and build certain rules or proxies to make it easier to, let's say, label data, build early prototypes, and let's say once you deploy those models and the virtuous cycle starts, then you start collecting more data, have more annotations, and keep improving and iterating over your models. So that's something that I think most models, if we see, started out with a modular approach and are then going towards being more end to end. So
Yeah, yeah,
that's the way
absolutely.
forward.
Because yeah, I agree. I think what we can see right now is while every it's important to understand that adaptability takes time, because while every voice to text platform today would market their systems with claiming that the word error rates are less than 5%. uh,
Mhm.
but actually when you try to use it, you got to sort of build your product with the right expectation, more realistic scenarios, where
Absolutely.
sort of you need to got to account for at least 10 to 20% error rates and build things on top of it
True,
to correct
true,
those things.
exactly. And you can't always go by a metric that holds true for a model. Because in the real world, even if a model is giving certain accuracy, which is good enough, but if it doesn't lead to a good outcome for the customer, then
Correct.
that model is not good enough, no matter how high the accuracy on a certain test set. It has to work in the real world for new customers, new conversations, and so on.
Got it. Got it. Cool. I think just one last thing. I think thanks a lot for your time. But one last thing is, like, what are your favorite people who you follow? What are your favorite labs which you follow? I think that would be good to know.
Right,
We are on the
right.
topic of, like, narrowing down, or like focusing within so many. Uh, how to better explore the research trends.
Sure. So I think the first thing is like to be aware of the general research literature in general, like and the history of that particular literature. Right? So I think reading some of the older papers gives you context as to how difficult, let's say, NLU was before deep learning came, before attention came, and transformer-based models, and how far we've come. So reading definitely gives you an idea, a broad overview, and then as you read, you come across ideas which are quite, let's say, challenging or new at that particular time period. And certain people tend to consistently come up with good ideas, and then you tend to follow those people or those labs or trust their work more than anyone else. But at the same time, there are always new PhD students or new people coming up with innovative ideas as well,
Great.
right? Sometimes coming from multidisciplinary backgrounds or completely new backgrounds, right? So, for instance, the CTO at Hugging Face has a background in physics and
Correct.
I think law as well, right?
Correct. Correct.
So, and they have developed such a good product and service, which is accelerating a lot of NLU research. So, I think in terms of my favorite labs, there are tons. I mean, also labs in neuroscience that I've been a part of for more than a decade, and let's say in AI also. And there are also a few labs that are both combining neuroscience and AI. So there is a sort of a huge repository of good ideas out there. Let's say with respect to NLU, I definitely follow the work that comes from Hugging Face, from Rasa. I think both of these companies have developed good open source systems, which are accelerating a lot of adoption for companies across the globe. In terms of research, I think the original Stanford lab work from Dan Jarofsky and others, and then their sort of PhD students have come in, so like Richard Zucker and others. They keep producing good work. So certain labs establish themselves as a mecca that there's a good learning ground, good training ground, and the people who tend to graduate from those labs then end up independently building a good set of careers and ideas. Yeah.
Got it. Got it. I think that's that's a good time to pause. I think I'll definitely go and check out some of those resources. Uh, cool. I think thanks a lot, Sandeep. Uh, Thank you for taking the time out. It was really a pleasure speaking to you. And yeah, I hope this is our second interaction. I hope we get to connect in future as well.
Yeah. Thanks a lot, Kripal, Pratik, and team for organizing this session again, and look forward to connecting again in the future. Thank you.
Thanks, Sandeep.